Come with me to meet the witch doctor.
Okay, so it is the next evening, and we're going to check our test results. I have to let you know that I couldn't wait last night, and I did check the sample that was done with the molten TPE, and it wasn't holding together. It came apart very quickly. So what I did is I used some heat. Not very much, but I did use some heat. I remelted the TPE again and applied it, and we'll see how that goes. Okay, so I'm going to get the first sample. This was the paste we glued together, and reasonably strong. I would say that did a pretty good job of solidifying two pieces. Let's check our molten TPE sample. I don't have high hopes for it. I've seen TPE. I've done it myself with a hot iron. I've spread out TPE and kind of thinking it'll melt in, but what it did was basically melt on the surface, but I was able to peel it off at some point later on. So yeah, it definitely has a place for filling large voids and things like that. Just that in this particular case. But anyway, let's see what the heat did. Okay, this is a lot better. Well, last night this came right apart. Oh yeah, it's reason. It's probably as good as the paste. I'm thinking. Yeah, there's some give here, but of course, when I heated this up, I I didn't go crazy. I wanted to redo the experiment really fast, so I heated it up quick. But it's showing me that between the cold TPE and the hot TPE, there's a big difference in its adhesion. So yeah, it's definitely a possibility. All right, so let's check the. This was solvent only. It was just xylene holding these two together. So let's see how that did. Uh, oh my. Wow. I'm gonna I'm gonna say that's probably the best bond. I'll be dipped in shit. I mean, I cannot see any. It's basically one piece. I mean, with the molten TPE, there's definitely some. Some of it's able to rip apart. You could see that. I mean, it's got a grip, and the paste is, I think, comes in second to the xylene, but I think this is number one. Um, yeah, I mean, that is welded for all intensive purposes into one piece. No heat, no nothing. Interesting. Well, so I'm going to call this number one. This came in first place as a method of getting adhesion, and it's a pretty good method because I like the paste because it's a gap filler. It can fill cracks, crevices, and still end up giving you a bond. Uh, and it'll take up some space where there is none. These are two perfectly flat pieces, well, not almost perfectly flat. So they fit together pretty good. I mean, if there were gaps in there, like if this was rough, I don't know if I would have got such a good bond. Uh, I thought more of the molten TPE. I mean, but then again, it's got some kind of a bond there, but it's a little more stretchy. I have to admit that, and probably because that hot molten TPE didn't melt enough of the cold TPE to bond really well. And like I said, I did heat it the second time around, and I'm sure that's why it got any bond at all. Um, yeah, interesting, interesting stuff. So I would say, I mean, if you have a situation where you've got a crack in a doll and it can go back together perfectly, um, maybe going with a little bit of xylene. If the mating surfaces are pretty much the way they were when they came apart, I would say this is probably the top dog right now. This has its place, but honestly, this stuff is really smoky. When I did this little sample yesterday, it did fill the house with a lot of smoke, even though I have a vent going. It didn't set the smoke alarms off, but it was there. I could see it. Um, Now you could make a hybrid where this paste is very thick. It's barely moving in there. You could take some of this, mix it with a little bit of xylene, and thin it down so that you got the strength of the xylene and a higher concentration of it to a higher ratio of it to TPE paste. If you really need this gap or filler effect, then you're going to need to use it like this. And I have used it this thick on Christine to rebuild her hip. So yeah, that's it. That's pretty conclusive, and I am surprised that the xylene did a much better job than the molten TPE. But of course, there are other uses for molten TPE too. I mean, if there's a couple of dolls where their toes came off, and I'll be dipped in shit if I know where they are. So, maybe it's not totally out of the question to mold a new toe. There's a lot of challenges in doing that, what the mold is going to be made out of. And of course, it's got to resist, super high heat. Uh, but yeah, I mean, my thoughts were, this would be great for large cracks. Um, and a more instant type of repair because it does dry very fast. When it not dry but cool. As it cools, it goes back to a solid form. And it's incredibly sticky. So yeah, I'm thinking that for the molten TB with high heat would be an option. For some, every situation is different, and they all have a purpose. If you need a gap filler, a large gap filler, I would say this would probably be the way to go. The advantage paste has obviously is the xylene that's in it to bond it. And if you watched any of my videos, you'll know that I do heat stuff up just to give it a little extra edge. Heat the TPE to give it a little extra bonding edge. I mean, you could take two partially heated up, melted pieces of TPE and stick them together, and they would have some bond. But this apparently is really the way to go, especially if you've got two pieces that are going to fit relatively well together. That's the good way to go. The problem with TPE a lot of times is it'll lose so much of its solvent uh, or oil, really, the mineral oil that it's made with, that it becomes dried out and brittle. So you really, when you work on a special area like the back of the doll I'm going to be working on is all cracked, and I'm sure it cracked because of gravity, because all that TPE is pulling down on the skeleton that it's connected to. But also it dries out. I haven't been that diligent to oil every doll every 3 months. It's perhaps I'll get to that point where I'm doing that, but really, ideally, that's what you want to do. Uh, and I guess that's it for now. That's the end of the experiment. So xylene by itself, number one. The TPE paste, number two. And this, yeah, number three. I don't really know if a combination of xylene and molten TPE, how well that would work. I don't know. Maybe I'll try it as an experiment. But yeah, as you can see from the camera, this is the better bond here. I mean, it would take quite a bit if you could yank it apart at all. Which I don't know if I could. Yeah, that's basically one piece now. Um, and xylene is a relatively strong solvent. I mean, you might get some kind of similar results with other products. I've known a few people on YouTube that I used to follow years ago. One lady used a DuPont chemical that was basically a type of adhesive remover for decals or something like that. I don't know. She swore by that, and I tried it, and it did work. Not quite as well as this. I mean, that TPE I made with that chemical was always lumpy. It never really dissolved into a true paste. I've tried lacquer thinner, so. Um, it wasn't until I tried the xylene that I've seen how well it melted this stuff. And obviously it does work well because it just bonded these two pieces into one piece. And the only thing that makes this a liquid TPE is the solvent. If I were to leave this cap off the jar and let that solvent evaporate, I would have this would be solid in a short period of time. All right, that's it. When I start working on Juicy, I guess we'll be filming again, which should be very soon. Had been considering using molten TPE on her back, but I may put some aside to do if the need arises, but I think I'm going to go with the xylene and let's see how that rolls. She's not too old, so I think I gave her 2 oilings so far, so she should have plenty of mineral oil absorbed at this point to do the work. Anyway, that is it, and I will see you on the next one.